Imagine mysterious visitors from beyond our solar system, objects travelling at incredible speeds, coming from places we've never even seen. What secrets do they carry? Could they change everything we know about the universe? Stay with me, because by the end of this video, the answers will shock you. These are interstellar objects like Oumuamua and Borisov, and scientists have been tracking them closely, trying to understand where they come from, what they are made of, and the astonishing possibilities they reveal about our cosmos. Before we dive in, make sure to hit that subscribe button and turn on notifications so you don't miss any of our space adventures. The unexpected messenger. For centuries, humankind has watched the night sky with wonder. We have mapped the constellations, followed the paths of comets, and catalogued thousands of asteroids. Every object we studied belonged to our sun, each one a child of this solar system, orbiting within the boundaries of its gravity. But in 2017, that understanding shattered in a single, breathtaking moment. Astronomers at the Panspermia Observatory in Hawaii detected a faint, fast-moving object, unlike anything they had ever tracked before. Its trajectory wasn't circular or elliptical, it was hyperbolic, a mathematical signature of something not bound to the sun. That meant only one thing. This visitor came from outside our solar system. It was the first confirmed interstellar object in human history. At first, scientists assumed it was a comet, but there was a problem. It had no visible tail, no halo of vaporized ice, no familiar glow. It wasn't a typical asteroid either, because its brightness fluctuated dramatically as it spun, suggesting a long, thin, almost cigar-like shape. Within days, the world's telescopes turned toward this mysterious traveller, racing against time before it disappeared forever. They called it 1I/Oumuamua, the first interstellar object ever observed, and its name in Hawaiian captured both the mystery and awe surrounding it, a messenger from afar arriving first. The shape of mystery. Oumuamua's behaviour baffled everyone. As it rotated, the light it reflected changed by a factor of 10 far greater than any asteroid known. That implied an extremely elongated body, possibly 10 times longer than it was wide. Some scientists compared it to a needle. Others imagined a flattened pancake-like shard. But its shape wasn't the only puzzle. Its motion defied gravity. When Oumuamua exited the inner solar system, it began accelerating slightly, as though something invisible was pushing it. Normally, comets show this behaviour because the sun's heat causes their ices to vaporize, creating jets that act like miniature rocket engines. But Oumuamua had no such tail, no gas, no dust, nothing that could explain the boost. This led to theories that challenged science itself. Was it made of exotic materials? Was it hollow, reflecting light unevenly? Or could it just possibly be something artificial, a relic of alien engineering drifting through the cosmos? Among those daring to ask this question was Harvard astrophysicist Loeb, who suggested that Oumuamua might be a form of light sail, a thin, flat object propelled by starlight, similar to technologies humans are only beginning to test. The idea split the scientific community. Many dismissed it as speculation, but others quietly admitted that the data didn't rule it out. For the first time, mainstream science was forced to consider the possibility that we had glimpsed technology not made by human hands. The race against time. Time was the greatest enemy. Oumuamua was travelling at nearly 315,000 kilometers per hour, far faster than any probe humanity had ever launched. By the time astronomers noticed it, the object had already passed its closest point to the sun and was racing outward toward interstellar space. They had only a few weeks to observe it before it became too faint to track. Every major telescope, from Hawaii to Chile to space-based observatories, scrambled to capture data. Spectral readings suggested a reddish surface, similar to the colour of organic-rich asteroids, and icy bodies exposed to cosmic radiation for millions of years. Its density appeared low, meaning it might be porous or partially hollow. The acceleration remained unexplained. When the last observations were made, Oumuamua was already fading, a faint dot slipping beyond the reach of human eyes. And then it was gone. The first visitor from another star had arrived, stayed briefly, and left without a trace, no fragments, no radio signals, no conclusive answers. Only questions, and a haunting sense that our solar system had just been visited. The theories multiply. In the aftermath, scientists offered a spectrum of explanations. Some proposed that Oumuamua was a fragment of nitrogen ice, similar to Pluto's surface, chipped away from an exoplanet and ejected into space. Others argued it could be a hydrogen iceberg, slowly evaporating in a way that produced invisible thrust. Yet others speculated it might be composed of frozen molecular hydrogen or solid carbon dioxide materials that could sublimate without visible trails. But none of these ideas fit perfectly. Each model explained some aspects but contradicted others. The data was simply too limited. As months passed, the debates grew more philosophical. What did it mean that we had seen something we couldn't explain? Was Oumuamua unique, or had countless others passed by undetected? For decades, scientists believed that interstellar objects were extremely rare. The odds of one entering our solar system seemed nearly impossible. But now that one had come and gone, those assumptions were collapsing. Perhaps the galaxy is full of wandering debris fragments of alien worlds, silent travelers drifting between stars, crossing solar systems unnoticed. If so, Oumuamua was not the first. Only the first we managed to see. The second visitor. Then, just as the world was beginning to move on, the cosmos spoke again. In August 2019, an amateur astronomer named Gennady Borisov spotted a faint, fast-moving object through his custom-built telescope in Crimea. At first, it seemed like any other comet until calculations revealed that its trajectory was hyperbolic, just like Oumuamua's. Another interstellar object had arrived, only 2 years after the first. This one, however, was very different. Unlike Oumuamua, Comet 2, I/Borisov displayed a clear, bright tail of gas and dust, unmistakable evidence of volatile ices evaporating under the sun's heat. Its composition resembled that of ordinary comets, with carbon monoxide, water vapour, and organic molecules. For the first time, scientists could directly study matter from another star system. The excitement was electric. Observatories across the world turned their lenses toward Borisov, measuring its structure, speed, and chemistry. The findings were both comforting and astonishing. Comforting, because Borisov proved that interstellar visitors could resemble familiar comets. Not every messenger from the stars had to be a mystery. Astonishing, because its composition was subtly different, richer in carbon monoxide, hinting at formation in an environment far colder than our own solar nebula. This was material forged under a distant sun billions of years ago, now gliding through our skies. A cosmic pattern. 2 interstellar objects in 2 years, after billions of years of silence. Was this mere coincidence, or the start of a pattern we had never noticed before? Astronomers realised that our telescopes had only recently become sensitive enough to detect such faint, fast-moving visitors. It wasn't that they had never come, it was that we had never been watching closely enough. Statistically, the galaxy must be filled with such wanderers. Millions, perhaps billions, of fragments cast out during the violent birth and death of planetary systems, each one drifting through space for eons until chance sends it across our path. Oumuamua and Borisov were proof of a vast, unseen traffic flowing between the stars, the cosmic equivalent of driftwood washing ashore from distant worlds. These fragments could carry clues about their origins, the minerals of alien planets, the chemistry of unknown suns, maybe even the seeds of life itself. Oumuamua was the first interstellar object detected passing through our solar system. Its unusual shape and speed baffled scientists, leading to theories ranging from a comet to a possible alien probe. Soon after, Borisov arrived, a more conventional comet, but still an extraordinary visitor from beyond our solar system. These objects give us rare insights into other star systems and the material that exists light years away. What do you think these cosmic visitors are really telling us about our universe? Share your thoughts in the comments below. We want to hear your theories, the seeds of life. Some scientists believe interstellar objects like these may play a profound role in the spread of life throughout the universe. The theory, known as Panspermia, suggests that the ingredients of life, or even microscopic organisms, could travel across space, sheltered within asteroids or comets, and seed new worlds when they land. If that's true, then visitors like Borisov and Oumuamua aren't just random rocks. They're couriers of possibility, messengers of creation itself. Imagine a fragment of an ancient planet carrying amino acids, the building blocks of life, drifting for millions of years through the void, finally landing on a young, warm, Earth-like world. Life could begin again, not from within, but from the stars. These are no longer ideas of fantasy. The chemistry of Borisov shows the presence of complex organics, the same molecules that form the backbone of life on Earth. The line between visitor and ancestor grows ever thinner. The next frontier. By the time Borisov left our skies, humanity's curiosity had transformed into determination. Space agencies began to design missions that could intercept the next interstellar visitor. The European Space Agency's Comet Interceptor, set to launch in the 2030s, is one such project. It will wait in space, ready to chase down any newly detected object entering our solar system, capturing images and samples before it vanishes into the dark. For the first time, we will not just observe a visitor, we will meet it face to face. Such missions could rewrite everything we know about planetary formation, chemistry, and perhaps even the origin of life itself. What we learn from these travelers may answer one of the oldest questions humanity has ever asked. Are we alone? Beyond the visitors. As Borisov faded into the black, astronomers were left with a strange new feeling, not closure, but anticipation. For the first time in history, humanity had witnessed the passage of objects born in other star systems. The realization was profound. The galaxy was not a distant spectacle. It was connected. Every few decades, maybe even every few years, the cosmos could send us guests carrying pieces of alien worlds. But the true question was, how many had come before without being seen? Until recently, the answer would have been none. Our telescopes simply weren't powerful enough. But now, with modern wide-field surveys and automated sky scanners watching the heavens night after night, we stand on the brink of a new era, an age when interstellar objects are not rare miracles but recurring discoveries. The quiet skies above may, in truth, be busier than we ever imagined. The hidden highways. Interstellar space is not empty. It is threaded with invisible currents, gravitational corridors shaped by the pull of stars, planets, and dark matter. Objects like Oumuamua and Borisov likely travel along these routes, moving from one stellar neighborhood to another over millions of years. These cosmic highways are not planned or mapped. They are carved by physics itself. When a young planetary system forms, chaos reigns. Planets migrate, collide, and eject debris into the void. Each of those fragments becomes a potential traveler, bound for the endless darkness. Some are drawn toward the gravity wells of nearby stars, passing through their systems before being slingshotted onward. Others drift in silence, never approaching another sun for eons. The Milky Way is full of such exiles, planetary refugees, wandering forever through space, each one carrying stories of its origin. It is this constant exchange of material dust, ice, and rock that makes our galaxy alive. Every interstellar object that enters our system is a piece of another's history, a fragment of someone else's beginning. The search intensifies. Since the discovery of Borisov, new telescopes have been designed to detect the next visitor earlier and more clearly. The Vera C. Rubin Observatory in Chile, set to begin operations soon, will scan the sky with unprecedented depth and speed. Its wide-field camera will capture the entire southern sky every few nights, creating a living record of everything that moves asteroids, comets, and quite possibly more interstellar messengers. Scientists estimate that once Rubin begins its survey, we could find an interstellar object every year. Imagine that each year, a new visitor from another world. Some may be rocky, others icy, and perhaps some unlike anything our instruments have ever seen. The excitement in the scientific community is tangible. Every new discovery will not only deepen our understanding of other planetary systems, but also bring us closer to answering the grandest question: what connects us all under this cosmic roof? The next mission. Humanity no longer wants to be a passive observer. The dream now is interception, to chase one of these visitors, to fly beside it, to touch it. The European Space Agency's Comet Interceptor is designed precisely for this purpose. Once launched, it will wait quietly at the Sun-Earth L2 point, ready to spring into action when the next interstellar object is detected. In a matter of weeks, it will launch toward the target, collecting high-resolution images and chemical data before the visitor escapes forever. Other proposed missions, like NASA's Project Lyra, envision even bolder ideas, deploying high-speed probes powered by solar sails or nuclear propulsion to pursue future interstellar travelers, perhaps even Oumuamua itself if it can still be reached decades from now. These plans, once science fiction, are becoming reality. The universe has come to us and we are preparing to go to it, alien or natural. Still, one question haunts both scientists and dreamers alike. What exactly was Oumuamua? Even today, no single explanation satisfies all the data. Some believe it was a fragment of an exoplanet's crust, polished by cosmic radiation. Others think it was a comet stripped of its volatiles, leaving only a dry skeleton of dust and rock. Yet a few still whisper of artificial origins, that it could have been built, not born, a drifting relic from an extinct civilization, wandering the stars long after its creators were gone. To most researchers, that idea remains unlikely, but its mere possibility has reignited our imagination. It reminds us that the line between science and wonder is thinner than we like to believe. The universe, after all, has never cared for our categories. It only reveals what we are ready to see. Echoes of distant suns. Each interstellar object is a time capsule. Its atoms were forged under a different star, within a different system, possibly billions of years before our sun was born. To study such material is to touch the ancient history of another corner of the galaxy. Comet Borisov, for example, carries a chemical signature distinct from any comet in our solar system. It holds more carbon monoxide and less water, implying that it formed far from its parent star, in an environment colder and darker than anything near our sun. That small difference tells a vast story of distant suns surrounded by icy disks, of worlds forming and colliding, of fragments cast into the void to travel forever. Through Borisov, we glimpse a frozen memory of alien creation. Through Oumuamua, we confront the unknown face of cosmic technology or nature's strangest artistry. Together, they are reminders that the galaxy's diversity is beyond measure, and that every star is a storyteller whispering its secrets through these travelers. The future of discovery. What lies ahead is nothing short of revolutionary. As detection systems grow stronger, scientists predict that interstellar visitors could become regular guests. Some may even be captured by our sun's gravity, becoming temporary residents in the outer reaches of our solar system. Others may collide with planets, moons, or the endless sea of dust that surrounds us, seeding new materials, reshaping the chemical fabric of our neighbourhood. If we learn to intercept and study them directly, we could unlock the secrets of planetary evolution, star formation, and perhaps even the conditions that make life possible. Interstellar objects might hold the clues to our own beginnings, the missing chapters of our cosmic origin story. And beyond science, these discoveries ignite something deeper, a feeling of connection, of belonging to a galaxy alive with motion and meaning. The human perspective. For all our technology, we are still fragile observers standing on one tiny world, looking outward with questions older than civilization itself. Who are we in this grand design? What role do we play in a universe that sends us visitors from beyond the stars? Oumuamua and Borisov remind us that exploration is not just about discovery, it's about perspective. They challenge our sense of importance, forcing us to see our solar system as part of a vast, interconnected whole. We are not the centre of creation. We are participants in a cosmic exchange, billions of years in the making. Every interstellar traveller is a whisper that says, you are part of something larger. And perhaps somewhere out there, another civilization has watched one of our comets passing through their skies, wondering, as we do, about the strangers visiting from afar. What comes next? The question now is not if another will come, but when. Somewhere in the deep, beyond the faintest stars, new travellers are already on their way, pieces of shattered worlds, frozen emissaries of alien systems, moving silently toward our sun. When they arrive, we will be ready. New telescopes will detect them, new missions will chase them, and new generations will look up at the sky, not in fear or confusion, but in awe, knowing that the space between the stars is not empty, but alive with motion and meaning. Each visit will bring us closer to understanding not only the universe around us, but the origins within ourselves. Oumuamua was the first, Borisov was the second. The next could change everything. Outro. In the end, these visitors are reminders that the cosmos is not a place we merely observe. It's a conversation we are part of. Every fragment that enters our sky is a voice from the unknown, a whisper of connection between worlds that have never met, yet share the same stardust. The night sky above us is not silent. It's full of messages waiting to be understood. As we watch, learn and prepare for the next encounter, one truth becomes undeniable: the stars are watching back, and the story of the universe is still being written, one visitor at a time. Interstellar objects remind us how vast and mysterious our universe truly is. Every visit expands our understanding and sparks new questions about what's out there. If you enjoyed this journey through space, Make sure to subscribe and turn on notifications for more cosmic mysteries. And don't forget to check out our other videos. There's a whole universe of incredible discoveries waiting for you.